We're going to put rocket thrusters on it. Ultra high pressure compressed air.
And how fast are we talking?
How fast do you want to go?
This is a story about how after 5.5 years of making YouTube videos, I actually got hit up to make a sponsored video by PCBWay. And I was like,
let's put rocket thrusters on it.
And then I did. All good projects start with a little bit of measurement and then design in the computer. Fusion 360. Here's a time lapse of the design. God damn. I'm getting giddy. This rocket's gonna go so fast.
Whoa! What the man?
Do it again.
Jesus Christ!
Hold them together.
Stop!
This opens the valve on the rocket bike. Let go. Click it.
He's like, I don't know what's going on with
He's
you.
like, I don't like that thing.
I don't like that sound. I don't really like that sound.
This entire sequence is me making a manifold for the low pressure tank. The low pressure tank is necessary to lower the high pressure to about 145 psi in order to drive the pneumatic piston that opens the ball valve, the main ball valve on the vehicle. I like to get parts nice and flat on my surface plate. Super glue. Now we're facing off the saw cut. We're gonna get to the right height. What's up, guys? So I have something to say about this. This is an interesting method I found myself doing a lot of recently. There's probably a couple reasons for this. I'll lay them out. One of them is because like I'm not very good at parting parts off. I'm terrible at it, probably because I'm too impatient. I'm gonna shave soon. Anyway, trim. I don't shave anything anymore. Too much information. Yes, so I cut it off in the bandsaw and then I like to glue it to this piece right here. I've actually thought about drilling a bunch of holes in this and making it a fixture. Tapped holes. Maybe I'll do that in the future, but this is actually pretty useful, and then I just super glue it in and I knock it off at the end. Sometimes I damage it knocking it off. It's only a bad thing. One thing I wanted to say is I could just cut this top off in the on the mill, because that's where it's going next, is to the mill. But I always find myself sticking it back in the lathe and cutting it off and doing it manually. And I've wondered why that is, because it's technically another setup. I think there's a couple reasons. For one, whenever you're using manual machines, you just do it. You just go over there and start like doing it. And then there's like the setup on, there's like more mental energy on the front end with doing CNC machining, because you're worried you're gonna crash the tools, so you're always thinking about it really heavily. And so I think that might be part of the reason. Versus here, I can just go set it up and just start working on it, even though I have to stop the machine, start the machine to measure it, because I don't have a DRO. I need a DRO on this thing. And then the other reason that maybe I do it is because I can take material off potentially a little bit more quickly on the lathe, but that's probably pretty even. So I don't know. I don't know why I do it that way. It's an extra setup, which is technically something you want to avoid. If I was doing 1,000 of them, I would definitely not do it on the lathe. But for some reason, when I do one pieces like this, I tend to do it on the lathe. Yeah. Let's go put this on the mill. Setting up my knockoff Saunders Machine Works vices with my V-block to hold round parts. Roughing. It's a finishing pass. Matching the curve of the PVC it'll go in. Adding lubricant manually to the holes I'm drilling. It's an inlet and outlet port that's being drilled. I drilled pilot holes on the machine. Now I'm opening to full size. Tapping with a 1/4 inch NPT tap. Now I'm roughing the PVC, prepping it for paint. These are the end caps. A little extra clamping pressure coming from my hands. That's very satisfying. Now we're gluing the components together, starting with the manifold and the cap, the manifold that we just machined. PVC cement primer, and then the glue. Painting this was very satisfying. Now I'm attempting to manufacture one of the connectors for the high pressure tanks. It'll be welded to the main structure later.
Not mine, it's not Bailey's.
Okay, I'm recording a video right now.
So I shouldn't talk about the unusual bra that was found in the house.
It's not mine, I'm telling you, it's not mine.
Well, then I've got to have a good conversation with your father.
Oh, God damn it. Ow.
Should we talk about this? Isopropyl alcohol? Great lubricant for aluminum, by the way. So I was spinning the thing, the wheel, grabbed onto it, spun it over, felt the pressure build, and then pop through my skin. Yeah, that really sucked. I'm pretty sure I bent the needle on my bone because when I started squeezing it, it squared out sideways.
It hit my bone.
Not good. I don't recommend that. Hopefully there's nothing stuck in my finger and I get gangrene. I really don't want that to happen. You know, at least the inside of the needle is sterile. Isopropyl. Now I'm continuing manufacturing the attachment point for the high pressure tank. This is a time lapse of the angled cut and chamfer to be filled with welds being cut on my mill. What's up, everybody? I was working on something. Let me grab it. And I decided to try to finish this one first. The other ones I was doing, you were seeing, that was the first one I was doing. I had to make 2 of these. And to put this thread on here, the die I got is really tight for some reason. I was having to grab the out of it to get it to cut. And I ended up having to get a pipe wrench, a monkey wrench. Monkey wrench. And this thing, these are really nice tools. They're actually kind of somewhat delicate tools. Sort of, but the thing was really on there, so it was really grabbing into the aluminum. So if you can tell right there, it's all cut up. And normally for like a one-off prototype kind of project like this, I would be okay with this. But the fact that this is going to be handling very high pressure, 4,500 PSI, 300 bar, these are essentially, I have like a safety factor of 3 on this, so it probably would be fine. But all these little cuts here are now stress risers, and I don't want this thing to blow off. This part that I'm making screws onto the back of the tanks, the scuba tanks, the carbon fiber scuba tanks. If one of those, this blew off, the scuba tank could go off one direction and take someone out, and I could go flying off the other direction, because now like the moment is putting me in a circle. So I just decided I didn't want to do this. So I made this off camera. I just drew it on there roughly with some bluing, and then I laid out the center and cut everything out. And this may seem like a little overkill. See, the other thing I could have done is I could have remade these bigger and then use the pipe wrench to put them on there and then cut that piece away. I could have done that, but I ended up making this instead, and this is the same diameter. And then it screws down, and I'm actually going to super glue this to the parts too, because it was really I need a lot of pull in order to get that to work. So this slides off, and then I laid out that inside. And this may seem like overkill, and I probably maybe could have figured out a way to do it for this 18 1.5 thread that is what's on the scuba tank. However, in a little bit, you're gonna see me try to use this guy, and I'm nervous about this guy, so I needed a way, and I'm already getting the pipe that I'm gonna cut this into coming from China. So I need a lot of gription to get this to work. So I made that piece, I'm gonna super glue that piece on, and hopefully that'll work. Hey, so I'm in here and I'm working on something. I'm working on squaring up this piece of material here. I'm doing it the way this old Tony taught people of YouTube, I don't know. Anyway, so you cut one side and you put that side down up against the jaw, and then you flip it, you make sure it's up against the jaw and against the bottom, and you flip it one more time, and you do that on all three sides. The back side doesn't matter as much. But essentially you're always referencing, I'm trying to say this quick because it's already been talked about, but you're always referencing the side that you just cut is flat either against this or the back of the plate. But how do you do it? One way to do it is just to hit it. You can tell it sounds solid. You can kind of feel it, especially in person. The other way is to get a feeler gauge. I'm trying to give you guys some useful information other than just also making a rocket bike. You take a feeler gauge and you try to stick it underneath, and you use the 1 thou. I think they only go down to 1.5, but you use the smallest one. Because if you can't get that under, it's flat. It's a good trick. Here, this big square piece, I'm making the manifolds, the main manifold for the entire system. It'll have ports for the pressure inlet, a pressure release, an emergency pressure release that's broken if the pressure gets too high, and finally an outlet for the low pressure regulator for the low pressure tank. Can I just say something? I'm still doing the unboxing for these parts from China, but it's just so nice to be able to get parts and not have to machine them. Because this I could have built this part, and I could have built this part, but it would have been a multi-axis or multi-setup and maybe multi-axis. Maybe could have done it on one setup on the 4th axis, but it would have been a lot of work on my light machine. And just getting this, not having to build it, just designing it, building it. Look at that fit. That's a nice fit too. Oh yeah. It's just really, really satisfying. I don't know if I've ever... This might be the first time I've ever received a machine component from someone else for one of my projects. Which is kind of cool. Can you see me? Sort of. There is a couple things I want to say about these parts, other than the fact that they're beautiful. They look really good. Couldn't have made this one really easily at all, so I'm definitely glad they got this one. I could have figured out how to make it. And in fact, what I want to say about these is a lot of spots on here, like these two parts butt together, and then they get attached by a laser cut piece, and I could have this could have been made as one part, but I was designing this to where I could make it all on my own small machines. And like, you know, these parts could have been incorporated, but instead they're going to be welded. I just figured that was better. For starters, it's less material waste, even though it's more setups. But it also made it to where I can for sure build them on my machines. So all these parts were designed to be made by me in case they didn't come through or something like that. And I also just kind of wanted to do that for, you know, reasons. Yeah. I mean, the other thing I want to say about this is I kind of like this way of doing videos, where I kind of focus on building like one or two or a couple like complex parts, show you guys how I build it, go through step-by-step process, but then the video might be kind of boring if I literally showed the video of me making all these parts myself. That'd be just a ton of machining, and it'd be slow and be like repetitive. So it's kind of, I don't know, let me know down in the comments what you guys think. But I kind of like this, where I focus on the parts I make. But their parts are so much bigger than mine, look at that. Especially that inside. Yeah, let me know what you think. Christian. Okay, I was trying to get it in the camera, but honestly, I don't think I could open up the lens wide enough to show you how difficult this is. Comment down below if you work on heavy machinery, because I'm wondering if anyone cuts taps these big. This valve body, I'm pretty sure was cast. Yeah, this is insane getting this on here. I have a breaker bar on the smaller wrench, which is already a big wrench, like an 18-inch wrench, or was it a 12-inch wrench? I can't remember. Yeah, I'm like barely gonna be able, because, you know, I think I might be done, even though I just bought a bunch of taps and die sets for MPT, like a complete set. Move this up because my arms are tired. I might be done with these type of connectors, pipe threads, because I might switch to the ones that use all, can't remember what they're called, but the ones that use all O-rings. Because this sucks. This is terrible. I don't like cutting these. The reason I don't like cutting, if you don't know, MPT National Pipe threads taper as they cut. So because of that, they tighten down and they seal when you tighten them, which is smart, sure. But it also means the more thread you cut, the more difficult it gets to cut. So this is getting to a point where it's impossible to cut. I'm literally sweating through my clothing, and my hands are getting bruised from working the wrenches. Yeah, this is wild. Yeah. Alright, I know what you're thinking. Dylan, it seemed like you had a lot of practice grabbing something like that. I couldn't resist. Last you saw me, I was trying to work on this piece, get that thread cut into here, and it wasn't working with that die. That was a bad idea. I had a bad feeling about that from the beginning. My backup plan was to always do this. I didn't know that Fusion 360 had built in. I didn't think it was so easy to do a. Do I have metal in my beard? To do thread milling. That's thread milling. I never get tired of thread milling. I think it's the coolest thing. For some reason, interpolating a thread like that, which is literally where you draw the thread with the machine, I just think it's the coolest thing, and it fits perfectly. It's a perfect fit. Shout out to Saunders Machine Works for their videos on how to do this. But yeah, I rebuilt this part. I added a little bit of thickness here because that's where the drill bit meets as you drill this. And there's on this one, there's a little gap. Mine was perfect. Apparently, I am better than China. I love you, China. Thank you for sponsoring my video. You got the jokes tonight, apparently. Yeah, so I rebuilt this, drilled it out, and then I milled that. I didn't film making that because I didn't want to. I had to figure out what I was doing. But yeah, we got thread milled, and now I know how to build the piece that goes on the other side. I'm gonna do it this way, and God, the thread is so perfect. Let me show you. Like, that was so much less effort and energy to go thread mill this than to try to use a die. I think the way they probably do those with like, if they're actually using dies like that, they probably have some kind of hydraulic system to drive it. Yeah, I don't know if you can tell how pretty that is. Like, I mean, these threads will literally come out like they're mirrors. I mean, this has got some oil in it right now, but it's just perfect. Perfect. I love thread milling. Why didn't I do this from the beginning? I don't know. I probably could have got China to do that too. But part of this is I wanted them to make it easier. I wanted to do some of the hard and interesting things because it makes for good videos and I learn more that way. So, threads. I really have to trim my beard. This puts a smile on my face. It's gonna be so cool. I got some of the parts in here. I'm just laying it out, just looking at it. And it's gonna be really cool. And quite terrifying. This aluminum was a lot of fun to weld. What's up, guys? You probably have seen me welding. That's what I've been working on. I've got some stuff I'm going to talk about here. So let me show you over here. So you can see here I have it. It's super messy. I'm sorry. I have it mostly. We're kind of mocked up right now. And the reason for this, I have this tie on. I'm going to do something like this. It's going to be a little more stable than this. But I won't explain all the parts right now, but what I'm doing is I'm getting the tank. These are the high pressure tanks. This is the low pressure tank to drive the piston. I have them all, and then they also attach to this middle beam. And then out here is where the exhaust comes out. There's a ball valve here and then the exhaust. Okay, so I have this 3D print here. Which just holds it all together when it's done, but I have it here like this, and then I have this guy right here that has a V in it, like this section right here, and then I have this clamped down, and then I have a piece of metal in here that I'm using to space this, just a piece of welding wire that I catted it at. This is, I think, 16th inch, and it fits right in there. So this is just to all hold it in orientation so that I can tack this and get it in the correct position, and then after I do that, what was I saying? Oh yeah, I'll weld the entire thing out. So, I don't think these welds would be to code if this was actually being used for what it's being used for. So I think I have some porosity down inside my welds. I don't have a perfect weld bead on the inside. So when you're welding pipe, you have to weld through all the way to the inside, and you essentially have to leave a bead on the front, the top, and the bottom. And I'm a pretty good welder. I am. I'm not terrible, but I don't think I'm that good. I'm pretty sure. In fact, I know I have some porosity. So, so this was designed with a safety factor, I think, of 2 or 3, pretty high. And then you'll see here that I've gone kind of overboard a little bit with the welding. Like you can see that it bumps over the diameter of the tube. So my hope is that that extra welds will keep this thing from blowing up and becoming a rocket in a way I don't want it to be a rocket. That would be bad. So I'm going to test it up to above its pressure rating. Definitely not all the way up to like 400 bar, but 450 bar was what the tanks were pressurized to. And I'm going to run it around 300 bar. I'll probably test it to like 350 or something. Hopefully I'll do that today. We'll see what happens. Yeah, but I'm going to get this tacked up and then I'm going to weld it. I'm going to remove all the tanks and stuff before I do all the welding, of course, so that the heat doesn't transfer through and melt. Stuff. We're on YouTube. All right. One more thing I wanted to add is that I'm back purging these welds. If you don't know much about welding, you have to shield it in gas. And when you have that weld coming to the bottom of the pipe, so the inside of the pipe, you don't want that to oxidize. So you have to purge it with argon. So I have a secondary hose coming off. I can control the flow rate coming off of my main tank, and then I'm gonna have the tops of these open. I have them covered with tape. I'm gonna let them try to fill. I'm trying to fill up these tanks to get all the oxygen out. Argon's heavier. I'm gonna try to get out as much as I can. I'm gonna probably leave this on for like 2 or 3 minutes before I start welding. So I've got the laser cut parts out. I did not film me taking these out of the plastic, even though it would have been satisfying, because I was irritated because one of the threads got completely gummed up for where the tank goes. So now I gotta fix that. And I'm irritated. I'm irritated about that. Yeah. Okay, so I'm gonna clean up all these and then drill all the holes. Might not film all of it because I've done a lot of that, but and then I'm gonna weld together all the plate. So like this goes here, that holds the cylinder. So I gotta get all this done. I'm hoping to get all the welding done. Maybe today, we'll see. So, this is a linkage. I just want to talk about it a little bit because I think it's cool. It's cool because what I like about there's a couple things I like about it. I like its simplicity. So the entire thing is, well, for starters, the body is just made from some hex bar, and I just had to drill and tap out the holes. You saw me doing that, and then to get the length, which I didn't show, I use an indicator. I measure it, and then I face it off, and then I face it off, measure it, and then I touch it, and then I use the indicator, and then I cut it in because I don't have a DRO. Anyway, what's cool, so I like the simplicity of the base of it, and then these things are, what are these called? They call them Heim joints in vehicles, and they have another term too, but they allow these things to kind of be attached off axis. Now I designed it to be exactly perfect, but it's not gonna be perfect, so this allows it to move around a little bit. And then the entire thing is what's called a turnbuckle, and it's gonna be a little tricky to show you, but there's a left-hand thread on one side and a right-hand thread on the other side. And what happens is if, I need a way to like hold it. Here. What happens is it tightens down if you spin it one way, and it opens up if you spin it the other way. You can see it or not, but probably got tighter. And if we go the other way, yeah, gets looser. So what this allows me to do is these are gonna adjust the tilt on the nozzle coming out the back. And that's important because I want the center of thrust going through my center of gravity. Like I want the vector of the thrust going through the center of gravity, and that should be stable. Though actually, if it's pointing up, it actually may lift me up a little bit. So it may actually need to come slightly above, which is where it's trying to lift the back wheel slightly. But that kind of puts that front wheel down a little bit and allows me to still steer. The other option is to kind of lift the front wheel slightly, which puts the thrust a little bit more straight, but then I'm going to lose control authority as I move faster. So it's going to be something we figure out when we actually do the testing. There. Linkage. Turnbuckles. Jam nuts. These things. So after you get them in position, these jam nuts come down here and you lock these down on here and no more spinny. So it's adjustable. It's really simple. And these things, I mean, these things are not, I don't know how they manufacture these things. They're not, I think they swage them on there. These are not simple to manufacture unless you're making thousands of them, which they do. So yeah, there you go. Turnbuckle is such a good word. I mean, it's fun to say. It's descriptive. It sounds old because this has been around a long time. Farmers use this stuff all the time to like tighten fences down. I love that term. I didn't know it for a long time. Then I figured it out and I memorized it because it's awesome. One more thing. I was thinking about the description of this. I'm not sure I explained it correctly, but this is a ball and socket joint in here. I mean, if you work on vehicles at all, which you might if you are watching this video because it's kind of vehicle adjacent, but these are ball and sockets. That's what allows you to these to be off orientation. And then I think that right there is swaged around that ball. I don't really know how it works, but yeah. Ooh, look at that. There's that motion right there. Yeah, yeah, yeah. Okay, so I was in the middle of installing the thrust test stand outside, which is why I'm sweaty and dressed like Texas Indiana Jones. This is my Indiana Jones shirt. I don't know if you can tell. It's kind of got the pocket thing. Yeah, anyway. But I got some stuff in the mail and I want to show you some things. So I'll be right back. Okay, I'm going to turn on some extra light here. Okay, so I did some machining off camera. I figured we had like mostly enough footage of me machining. But I made, and I also kind of just wanted to get these parts done too. I didn't want to document every single part. So, but they are nice parts. They're kind of complex parts, which means depending on how you look at it, they're either technical or boring. Probably a little both, but I did get some video of the thread milling. I think it was on this piece right here. Anyway, I made these two parts, and I want to explain to you how they go together. So I have this part right here, and this has got a pipe thread on it, and it screws into the ball valve. Now remember, the ball valve is what's throwing. It's the main part of this entire thing. It's the valve that throws open and shoots me forward. It's gonna be intense, really, really fast. And then the thing is about these MPT taps threads is they're not really super reusable. They kind of break down because they're tightening against each other in order to form the seal. So I made this piece, and then this piece goes here, and it screws down like this. Okay, but before I do that, I'm gonna show you this. And I actually haven't tested this, so we're testing this part together. I tested another piece before, but an O-ring fits right in here. Let's see if it fits. Oh, it does. And it's actually not supposed to go there. It's supposed to go on here. It's not quite as tight as I would like, but it doesn't seem to fall off. Okay, so there's two types of pipe threads. There's this type right here, and we're gonna pretend this is attached to the ball valve this way. This is tapered. I don't know if you can tell. You can kind of tell, I think, on the video. But this is tapered down. And so when it tightens in, it tightens up against each other, and that's what causes it to not be super reusable. And there's another type of pipe thread, which is just a straight thread, a normal old thread, and then an O-ring, and then there's a cavity in here where that O-ring sits. Now, this is not a standard size. It's a custom size that I designed. I just picked the number of threads in here that I wanted and set the OD and the ID, and actually had a little bit of trouble with it, but it mostly worked. So right now we're about to figure out if this goes together and how. satisfying it's gonna be. Oh yeah, oh yeah. Oh yeah, that's satisfying. That is super satisfying. Okay, so that formed a really good seal there. I mean, this is probably overkill. I could probably just get away with a normal thread because it's such a transient event. I would have a little bit of loss through here, but why? Why do that when we can add an O-ring for a few bucks from my MacMaster car? So that's that, but you might be wondering, okay, Dylan, there's a big hole though. What is that? So then you need a nozzle. Now I'm gonna use 3D printed nozzles. At least I'm gonna endeavor to use 3D printed nozzles because I think all the force of this will be handled by this outer piece here. And then hopefully it won't get blown out the back. That's the thing we're worried about. But so this is the nozzle. So I'll tell you a couple things about it. This is the outlet side. So it's a converging diverging nozzle. It'll stop the exit velocity. The exit pressure, as soon as the pressure in the tank gets to 600 psi, the pressure here will be 1 atmosphere. And then as it drops below, this will get less. And there might be some flow separation at the end, but we're not gonna worry about that because it's a tiny little cold gas thruster. So anyway, this one, it's hard to tell, but I have it printed on there. And I'm not sure if you're gonna be able to read that or not, but it says 364.3 pound force, LBF, and that's roughly 1.5 newtons, G's. I forgot my squiggly line to show that it's just a guess of 1.5 G's. It's not exact because I could change in weight. Anyway, this also has an O-ring on it right there. I have the focus set at a specific spot. I wonder if I can focus it. Yes, yes. Oh, that's nice. There we go. Okay, so that has an O-ring on it, and then that obviously has an O-ring on it here. So then this goes in here like this, and this is really satisfying. It fits really good. I had to make a couple of these to make sure it fit right. But you can see that's your converging side. That happens much more quickly than your diverging side, which is actually hard to even see up in there. There you go. So there's that. And then we'll just show you one more time going together. Oh, it's so satisfying. And this you can get really nice and tight. And then this little lip right here is where the tension, or I guess compression, is happening. That keeps us tight. And then this goes like that, and then that is the entire thing. Pretty cool, huh? Yeah. I'm gonna go finish putting this thing together and then I'm gonna take a shower. Bye, guys. The one thing that could happen is that, especially on the smaller nozzles, this is 1.5 Gs. I'm going to start all the way down at 1 or 0.5 G. This hole's going to be a lot smarter. Oh, I can't talk. Smaller. And then the air pressure building up behind this, I'm worried about it literally blowing this out the back. I really don't think it's going to happen because this thing is like, that long. It's a lot of plastic to push out, but it's also 4,500 PSI. But it's not actually 4,500 PSI because it's moving, so the static pressure is much lower. So it's not actually 4,500 PSI sitting there, it's some number less than that. One way to find out. What's up, guys? We're about to do a pressure test on the tanks and the tubing and the entire thing you've been watching me build. And the light's getting really bright now. Anyway, let's go over the safety features here real quick. It's probably excessive. I think you saw me fill the tanks with water and then fill the tubing with water. And I have that on the other side of the fence. Where's my finger? There's my finger. Yeah, right there. And then this is a bit overkill because there's not that much pressure in the thing. This is all full of water. There's not much explosive potential in it. But I have it behind this fence and then kind of around that brick wall right there. And then I have this fence, got about 100 pounds of weight over here. So if this pushes towards me, it has, I mean, that because that moment arm is like thousands of pounds I'd have to push with. And then on this side, I have my pump sitting up on an apple box. And then I just have this piece of MDF as some like shrapnel protection. Again, this is all pretty excessive, and then I also have this. I'm at like 300 psi of 5,000, and I got a leak, so I can't pump faster than it's leaking. Christ. What's up, everybody? So I have got, well, I was trying to pump this thing up with to do a pressure test of the pressure vessel and the welding and all that. Sorry, I'm outside. I don't have a ND filter on, so I might be a little blown out. And then I got the hat shadow. Anyway, I tried pumping that thing up with the hand pump, and that did not work. It was going to take like, I was exhausted after like 20 minutes, and it was going to take like a day. I got 24 hours to pump up. That wasn't going to happen. So I bought a $400, close to $500 pump, which went all of my margin for this entire project. So like and subscribe, please. Anyway, I've got it set up. I'll give you a quick rundown of the setup here. So I got the pressure vessel back there. You can't really see it, but it's under that blanket and on top of the blanket. And then I have some water in front of it in case it blows up. That'll kind of hopefully absorb some energy. I have it back here in some in the corner of this wall that'll also absorb some energy, and then I have it behind the gate, the pump. So the pump is right there. There's a pump and then the water cooling it, and then I have that kind of some shrapnel shielding, and then I have some weight on this gate so it doesn't pop open. I should lock the gate. That would make a lot more sense. Sometimes I'm smart, sometimes I'm an idiot. Okay, it's probably overkill. I mean, the entire thing is designed with a significant safety margin, but some of those welds are a little bit questionable. Probably what would happen is it like pops a little hole and then starts to depressure. But you know, there's always a chance that there's a violent disassembly. So I thought I'd be cautious. Yeah. I'm not going to be working the camera a ton while I'm doing this because I'm going to be trying not to die, and it's going to take like 30 minutes for this to pump up. But I'll show you what I can. Yeah. Okay, it's pumping up right now. I have it set. I paid $30 more for the one that has the pressure set off so it doesn't blow up. I have it set to 1,000 psi. I find myself thinking, as I do, about how to make things better. If you were to make one of these, you want an integrated one with a battery. There's a different type of pump. I'm not exact. I think it's just a piston pump that this thing works on. If you used a piston pump, a variable displacement piston pump, I think you could pump something a lot faster and more efficiently. Yeah. We're not building the second model yet, but it's an idea. I put some protective equipment on as well, just to be safe. We're at 2,000 psi. I just set it to, I'm doing in 1,000 psi increments. Just set it to 3,000 psi. We're going for 4,500. And then I probably will only run the machine, the bike, at like 4,000. That way I have a little bit of a safety margin. I mean, the thing is designed with a higher safety margin, but we're not testing to a higher safety margin because that pump only goes up to 4,500. So that's what I'm thinking right now. Okay, so you can see it geysering off over there in the corner. Maybe you can see it. There it is. Anyway, it's geysering off over there. The MPT taps or joints were leaking. A couple of them more, so I got to redo that. We got to about 3,250 psi. Yeah. I had to stop the pressure testing at around 3,250 psi, I think, because the NPT, National Pipe threads, the tapered threads, were leaking. And one of them was just a plug that I had for this guy. This is the pressure regulator that drops the 4,500 psi down to 150 to control the piston. It's just like a high pressure regulator for like a welding system. Anyway, I had a plug there, and then really that's not the greatest test because I needed a standoff for this, which is under a lot of pressure, and so I made it off camera. So this is what I'm trying to talk to you about right here. In this moment, I probably didn't absolutely have to test with this because this has a safety factor of like 20. I just checked. Sorry to curse. Sorry YouTube for cursing. People watching this, it's okay. You can handle it. But anyway, this screws in here, and this stands this piece off because I have a bunch of other plumbing that's about, yay tall. This stands this off so this can come off. And then there is this guy right here is a low pressure out, I think. Yes. And then you set with this thing. So we got that done. So the next thing I'm gonna do, I think I'm gonna use a cap on this. And then I was just looking at the MPT tap on this because there's another piece that came with this thing for a high pressure tank. I took it off and there's like some dusty stuff on the thread, and I think I always used Teflon tape, and I think that's not maybe the best stuff for high pressure. I think there's goo that you can put on these things and it works better. So I think I'm gonna try to go buy some of that goo and try using that instead. Because I had some of these threads on really tight. Like I have another one that's leaking too. So I think I'm gonna try that on the ones that are leaking and see if it works better. I might do some research on it. If you know, down below, comment and tell me what's the best way to get a high pressure seal on an NPT tap. By the way, I tend to read most of the responses. On some of the bigger videos, it's a little overwhelming to respond to all of them, even though I read them all. But most of you guys are lovely. Every now and then someone's an asshole. But most of you are lovely, and I really appreciate it. Just wanted to tell you that. It's true. The response I got to the Mark 1 video was very heartwarming, and I wanted to respond to things, but I didn't respond to all of them. But I do read them all, pretty much. Hopefully I'll get to a point where I can't read them all. That would be the hope. But for now, I'm definitely reading all of them. All right, back to work. Okay, so I popped the tanks off after the last test, and then when I was putting it back on, this thread got completely manged, and I eventually just had to tighten it all the way down, and that's not coming off. It's definitely not coming off and going back together again. So this is now assembled in its final form. I am a little worried that this thread now is the weak point. So if it fails, I'm sort of expecting it to fail there. Hopefully it doesn't fail. I'm gonna bolt this thing together a little bit because I just feel like I want it together a little bit more to take strain off of some of these things when it's being moved and stuff. Yeah. maximum pressure, which is took 3 times, third time's the charm. And like I said, I gnarled on that one of the tanks. It's on there for an never kind of way, so I'm glad it worked because it's not coming off. Good, I'm happy. Next is firing tests with on the thrust test stands with just gas. See how much thrust we're producing. Then after we do a bunch of those tests, then we'll do tests on bike. Okay, so I really wish I would have known about that sealing compound for MPT threads for hydraulics. The main valve, the main big ball valve, is leaking, and that's very annoying because I have it kind of assembled, and like I said, I can't get those tanks off. So now I'm sitting here wondering if I should try to pour some glue down in there. I could try to epoxy around it, try to keep that sealed, or I could try to take the valve off and put it back on, but I really don't want to do that. You learn doing this stuff, obviously. It's a thread lock, like 565 or something, sealant. Yeah, right now I'm gonna go depressurize the system, so it'll be cool to watch. All right, guys, I made some parts off camera. You know, there's only a certain amount of like machining you can do on camera before it gets kind of boring. Unless you have a real knack for it, like inheritance machining or something like that. I'm not sure I have the knack for it. Anyway, I also my camera chip was full. So I made some parts off camera, and this is some linkage stuff I'm gonna show you guys. Obviously you're gonna see this all attached, but it's gonna be like, this thing is gonna move so fast you won't even be able to see it. That's the goal anyway. So this is the lever thingy to open the valve. So this is a pneumatic piston. And this is the end, the tie end that came with it right here. That goes on the end, and then this angle, this thing right here, this slot goes on the ball valve stem, which is over here. And it's set up like this-ish, yeah. Kind of like that, and then kind of like that, and then it pushes like that and opens it. It's this cool mechanism that I just played with in CAD until I got it right. And the parts I machined were this brass piece right here, which has a shoulder, and then also put together. There's a shoulder and down, and then a little circlip to hold the cap on. The cap is right here, and so that is that. It's also very satisfying. And then I just put a bushing in between here. I initially thought that the ball valve would hit a wall, and I realized I don't know how ball valves work. Once you take off those parts that hit the wall, there's nothing to smash into it. So I thought I needed a bushing in there to kind of dampen the force. So I made a Teflon bushing because I still had it designed that way. Actually, I already had these cut. So yeah. Anyway, I think I'm going to get this thing assembled. Yeah. So I've got this partly assembled. I have to get some, I think I'm getting tennis LL. Anyway, I've got this mostly assembled. Got all the stuff tightened down. I should have showed you, I forgot. Sorry, I haven't been super great about filming today. There's a lot of stuff going on. I also don't want to bore you, but I did glue around this joint. If I really had to get this off, I'm sure I could. It's not like a ton of glue, but it's hopefully enough to at least limit the leakage. Okay, so I've got the piston attached here and all the valves. And then I want to show you this, because I was talking about it a second ago. This is the reservoir, the low pressure reservoir here. So this is the regulator. It pulls air off and then comes to here, and then it goes through this guy. Oh, there's a button there. Interesting. Anyway, it goes to this solenoid, and that activates this. So this pushes forward and back, so I'll show you this. Like that, which is, I love that. That's very, very nice. So this is the piston here, and then it's turning. This is anchored down. You can't really see it, but this is the ball valve, the main ball valve that opens the rocket and lets it go. So air gets pushed up into this valve right here, this hole, and pops open and smashes this open very, very, very quickly. Yeah, isn't that cool? I think it's a lovely mechanism. I think a 2-bar mechanism or something like that. There's a term for this. And there's actually software about making mechanisms like this work, but it was not complicated, and it was not overly complicated that I couldn't figure it out in Fusion 360. So I built this in Fusion. Yeah, I'm gonna get those fittings that I made tomorrow and figure some stuff out tomorrow, the next day, and then I gotta put the strap around it to hold this all together. And then I'm done with the main unit. There's stuff to do for the actuate to turn on off, and then there's all this stuff to attach it to the bicycle, which I have partly done, but we're making progress. This project's always going longer than I expected it to, but we are making progress. It's very cool. Yeah. What's up, everybody? Out here, and I have the, I don't know if you've seen any of this. I have the system here. There we go. I have the system here on the table. I have it bolted through, let's see, right around here-ish. There's some bolts coming through, tacking it to the, bolting it to this sled here. So, let me back up a little bit. So the thrust test stand, the green thing, is bolted to the concrete pad. There's some bolts here. There's threaded inserts that fit in there. And then this piece right here is on some linear rails. And then up underneath there, which you can't see, is a load cell to measure the thrust. And then bolted down here. And then I have this towel over it to keep the, because I have a tie down, also attaching it so that it can't lift like that way. And then I have this just kind of protecting it. So you can't quite see all of it, but there's the main thing. And then we got the pump back here, and I'm currently filling up the water bucket as we speak. And then this will eventually be mounted to my handlebar. Turn it on, you can see right there the light goes on, and then turn this like this. That's arms, and then press it and you'll hear a click, and that's throwing the here, I'll show you. That's throwing, that's all wired up over here to this guy. This is a 3-way valve. I think I have it, I might have it backwards, so I may have to change these tubes around, but that controls the piston, and the piston throws open the solenoid, or not the solenoid, the ball valve. So it comes out. There you go. You see how that moves? So that's how it slides. So this comes out like that, and so when this shoots out with a lot of pressure, it'll open this extremely rapidly. Here's our nozzle right here. Okay. And then last piece of the puzzle is just I have a little display over here, and this is wired underneath to the load cell, and that's how we're testing everything. Sorry for the shaky cam work, but yeah. So I got all this together today. I wasn't sure for sure if I was going to test it or not, but I think I'm probably going to do one test of the smallest nozzle, at least one low pressure test, if not a high pressure test, of the Smallest nozzle. The smallest nozzle is the one that's most likely to fail because it has the smallest hole. It's holding back the most amount of back pressure. Like a big old hole, I don't think we'll see as much pressure. So start with the one that's most likely to fail. If it fails, it'll probably go shooting across to the gate over there, fence, whatever, wall. And then, so if the print settings and everything work on that one, that'll print the rest of the nozzles, and I will test every single one of them just to make sure, and also get all the water out of the system. There's still some water in there, I think. And then after that, I'll get it off the test stand and put it on the bicycle. Yeah.
Okay, this thing's leaking like crazy, so I'm just gonna test it, and then I gotta break it down and do some more stuff to it. Okay, you ready?
Yeah.
Full test fire.
Wow. You should have on hearing protection.
Hey guys, so I was in the shop. I did this off camera because I didn't think it was going to be very exciting. Yeah, the hole is the same size, but so this is the 3D printed nozzle. This is one of them. This is the 1G one, and I had in there the half G one. These are the same height when they started. Look how much shorter that is. That's a solid 1/4 inch. I printed these at 70% infill. I think I'm probably going to reprint them at 100. It feels denser now than this one. I had to tap it out. Oh wow, look at the words. The words got all shrunken down. I don't know if you can read them or not. They're like squished this way. That is so wild. I mean, it makes sense. It's like, let's say it's a square inch. It's probably close to a square inch. That means there's 4,000 pounds sitting on this. I guess I should have realized that that's what would have happened. But that is nuts. That's nuts. God, that's a lot of force. Just realize, like, you know, that's a great example of just how much force this is. I'm really bummed. I was filming the load cell, trying to figure out how much thrust that was, and I didn't hit record. I'm sitting there with my phone just looking at it. I think I saw it get over 100, which was, this was supposed to be 120. I think I saw 115. So we might be like really close, I think. But I wasn't looking at that. I was kind of looking at everything. So, because I thought I would just look at the recording after. So I'm probably going to reprint these at 100 infill. I didn't print all of them yet. I was doing a test. So tomorrow I'm going to do 2 more tests, and then I'm going to get this on the bike. And then I don't want to test this forever. Also, it takes forever to pump this up. So I don't want to do it like... I don't want to do like a million tests on the stand. I want to do some tests on the stand. Once everything's good, we're just going to put it on the bike and go from there. The piston is for some reason angling up, and I can't really figure out why, other than maybe it's running into itself and then it's pushing itself up. I think that's what's happening, which is weird because it shouldn't do that. But that's a weird failure. But it seems to be working, and I'm tired of with this thing. So I think we're just going to go ahead and put it on the bike and get some testing done soon. Yeah. That was really exciting. It was very loud, very cool. I just noticed something else interesting about that back in the shop. Sorry for the change of scenery, but I just noticed something else about this nozzle, which I think is cool. The length ahead of the O-ring, here's the O-ring. The length ahead of the O-ring is the same length. So all the compression happened behind the O-ring, which makes 100% sense. Because this was under, you know, this is even force around this part, but then behind it, crushed it. That's even cooler, if you ask me. Is it even smaller at all? I don't think it's smaller at all. It's so wild. Yeah, it's not smaller at all. It's like the same exact length. is like the same exact length. So all the crushing happened in this little piece right here. That's insane, man. So much thrust. Another thing that happened is I think it was because it was like slightly porous, it actually blew out the back wall. So I think there was like obviously most of it was going to be coming through the gaping hole, but probably some of it was pushing through this outer area too. This is the worst case scenario because it's the smallest one. I tested the smallest one first. So this one mostly worked and it's not even 100% infill. So I'm going to put the rest of them at 100% infill. But if this one works at 70%, the rest of them will definitely work at 100%. So it's going to work. Okay. 3, 2, 1. Yeah. Yeah, we're fine. Sorry about that. Thank you. Okay, guys, that was pretty awesome. I need to trim my beard, take a shower. I'm filthy right now. I've been sweating my ass off out here. It's hot as hell in New Mexico. All right, now I'm not complaining. That was really cool. That was the biggest nozzle, which is literally like the largest size that I can put on there. Let's say a couple things about it. One, the piston is moving, so I'm gonna strap something to it to hold it down. I think it's something to do with my double jointed thing. I think something is causing it to kind of yank and pull it down, which is the opposite direction of the pushing force. So I think it's something's causing it to yank down. I'm just gonna throw a strap around it. I would have made the mounting point stronger had I known that was gonna be an issue. I'm not too worried about that. One thing that's interesting is I did a slow motion recording of the I don't know if you're going to be able to see that. I'll just put it up. But I did a slow motion recording of the load cell, and I got up to a thrust of... I had to get out of the sun. That's why I moved. I was recording the load cell while I was doing this, and I got a max thrust, I think it was 363 pounds, which that nozzle was supposed to produce 730-ish that would be 3 Gs of acceleration. I'm not sure I was actually ever going to go that fast, because that is really, really fast. That's like beating almost all supercars. So there's two things that could be happening. It could be that for whatever reason, I don't think my numbers are wrong because I've been running way more complex numbers on other things, and this is actually a pretty easy calculation for me at this point. So I think my numbers are right. But I think maybe two other things could be happening. I think maybe the air is cooling down so fast that would change the mass flow rates and the thrust and stuff, which is also probably going to change the total impulse that I can get. So I'm probably not actually going to be able to hit 60 miles an hour because the air is cooling down, which makes it less efficient. It lowers the ISP. So I think because the ISP is lowering as it fires because of the cooling down, because as air expands, it cools down. The ISP drops, and then I'm not going to get the same amount of total impulse. So I'm thinking I'll be lucky to get to like 45, 50 miles an hour, which is still really fast on a bicycle. So not too worried about that. So there's that. That may be affecting somehow the top thrust, but the temperature should be at that point when the thing first throws open. So the max thrust is going to be right at the very beginning. So it's probably not that. It could be maybe the speed at which the nozzle is opening, some of those things. Or it could be the fact the load cell doesn't have a very super fast refresh rate. And so it actually did spike up at 700, but by the time it took the sample, it had already dropped down to 300. That's possible with how fast this thing is opening. I'm not sure. The thing to do will be to test it on the actual bicycle and start off with the small nozzle and then just go for the bigger and bigger and bigger nozzles and see how I'm feeling and stuff. Yeah. Yeah, some of the hoses on my thing have gotten they got hot and then they expanded to like two sides their volume, which is scary. So the worst thing that would happen is if I open the valve and then one of those hoses blew and I wasn't able to close the valve. That'd be bad. So I'm probably gonna have to replace those hoses. There comes the clouds again. All right, it's fun testing. It's gonna be a hell of a lot more fun to actually put it on the bike. Yeah. I don't know if you guys could tell from the video, but that was really loud. Like my ears, like I probably should have had ear protection on. It was very transient. It wasn't like a rifle round or anything like that. But like made my mom's ear ring. She was sitting over there watching, and then the neighbors across the street, like, "You guys okay?" Like, "Yeah, we're good. Thanks for asking. Just over here testing rockets." All right, 3, 2, 1. You all right? Sorry. Can you see that? Yeah, there we go. All right, so I overlooked something, and I've essentially made a wheelie machine. I'm barely lifting this front tire. You can see how it like wants to float. That'll be better with me on it, but ooh, there's some whip going on too as I went back and forth. This is so sketchy. Holy fuck. Okay, so I've got a strap. This is an old belt that I made many moon ago. My light just died. Here, I'll go this way. Yeah, this is gonna hook on to the handlebar. Got the bike over here. Hook on to like around this bar right here. And that is going to keep me from flying off the bike since I will weigh, well, it depends on how much thrust we actually get, but potentially like 2 or 3 times my mass in reverse. So this just holds me on there. That's the last thing to build. I'm trying to, I might tune up the bike. But other than that, I'm like getting very close to testing. And so I'm also kind of like, what's the word? Stalling maybe a little bit. Cause it's scary. Hey guys, I'm out here in my back porch. And I've got the pump here, the cooling system, and I've got the bicycle tied to the table that I have this on. It's all sitting on a table. And that's because this doesn't have a kickstand. This thing vibrates all around, and I don't want this to sag down and fall down. You might notice something nice about my bicycle, and that's that it's clean for the first time in years. And the reason for that is I called a local shop called High Desert Bicycles, and I went to the west side, asked for Ben if you go there, because he hooked me up. did a detail on my bicycle free of charge, which was super awesome because I'm broke. Hit that subscribe button. And he did a bunch of things. He made the brakes pretty. He like surfaced the brakes. He gave me some of these things, some pedals with some hooky thingies, free of charge. He replaced my chain. He straightened up the wheels a little bit. I think he bled the brakes and put new fluid in there. I forgot to ask if he did that, but I think he did that. So anyway, this bike is in like good, nice, perfect condition for riding and testing and, you know, somewhat risking my life on a little bit, though maybe it's not the craziest thing anyone's ever done. It's a little dangerous for sure. So yeah, the bike's good to go. I rode it fairly hard yesterday just to make sure everything was working good. And now I'm about to put some air in the tanks, and we're about to do some low pressure testing just in my neighborhood, and then we'll do some high pressure testing at a drag strip that we're gonna go to. Yeah. Ben wanted me to disclose that if I hurt myself on this bicycle, it's not his fault or High Desert Bicycles. That won't happen though. Nah. I want a bunch of sponsor stickers on here, like a NASCAR driver. I'm really not a huge fan of like advertisement like this, especially if I make my Iron Man suit and that works. But I don't know, something about the bicycle looks good with like some stickers on it. I need a PCBWay sticker, but also PCBWay is literally in the bones of this entire build and started this entire build, so maybe I don't. I have one, but it's like giant, so I need like a sizable one. Maybe I'll put the giant one on there, let's see. Okay, we just did another test. I'm on my phone. And I am absolutely drenched. It wasn't that hot out, and I wasn't pedaling that hard. I think it was the adrenaline, so I got a little adrenalized when I first shot the thing, which happens when you do somewhat dangerous things. At least to me, it happens. It wasn't bad, though. It was fun. Honestly, it was so little. I could feel it kick at the very beginning, and then after that, there's like a slight push because it was only 2,000 PSI, and it was the smallest nozzle. All right, I'm out here the day before we do the, not really testing, but going for it. So I'm going out to the track tomorrow, drag strip. One thing about riding this that I wanted to talk about is that the support structure in here, which is across there, down through that, and then up into here. That triangle is not very large, which is probably a design flaw on my part, which means that this thing wobbles quite a bit. I don't know how much that's going to get worse at high speeds. It seems to be when I like kind of move the steering wheel, it kind of oscillates through the bike. So it's just something to consider. It's a little sketchy. It's fun though. Oh, I thought I was recording, but I wasn't. Man, this beard is ridiculous. I've also been editing my video, and I realize how many times I've said my beard is ridiculous, but it really is ridiculous. I'm an animal. I'm exhausted, by the way. I did not sleep at all last night. I had some stuff on my mind. One of them being, you know, this shit. Trying to break, probably land speed records. We'll probably break some records today. First run done. That was good. I was really nervous doing it to start with, but once I got going, it felt real good. All right, that was the first one right there, the first run. That was a lot of fun. We're filling up the water again to do a second run. It was really exciting. I definitely had adrenaline going when I first started. And we had hit some wobbles when we were going, which has everyone concerned. I'm not super concerned. I didn't stop going. If I was super concerned, I would have let off. I think what caused it is I was a little wobbly when I started, and it just continued as I was going. So the plan for the next one is if I have wobble, I'm just going to abort and then come back around and try it again. So that's the plan. That was really fun. That was really fun. All right, I got a couple things to say. I watched that video. That wobble it looks worse than it felt. Man, it was fun. That was really, really fun. It was really a thrill. I'm not much of a thrill guy, honestly. I didn't like roller coasters and stuff when I was a child, but that was fun. Whew. And then there's something else I wanted to say. This bicycle I inherited it. It's a long story, and I won't go into all the details, but my sister's boyfriend died of a heart attack, and I inherited that bicycle from him. And it was interesting to me because it's kind of a wake-up call for me, because me and him were both working really, really, really hard on things. I don't know if that's what contributed to his heart attack or not, but it made me, what's the word? Kind of reevaluate some of the things I was doing in my life. And that bicycle is awesome. I love that bicycle that I ride. I actually ride that bicycle all the time. It was like the only nice thing I owned for a while because I was so broke because everything was going into my projects. And Connor had good taste, and that bicycle is very nice. And yeah, I wanted to dedicate this video to him. So yeah, it's for you, Connor. Rest in peace, man. I'm drinking Red Bull right now. I love Red Bull. I drink it when I travel a lot. I don't drink it very often because it does have a lot of, well, probably shouldn't drink these like all the time. But I drink them when I travel, and I drink them sometimes before I do things like this. And what I'm trying to say is, Red Bull, you should sponsor me. Listen, my goal is to break the speed of sound in a suit of powered armor. This video is just for fun. And literally, your slogan is Red Bull gives you wings. I mean, come on, right? And also, if Red Bull doesn't sponsor me, it's because they think I'm just gonna shout out their drinks before every video I make, and they think they can just, get away with like free advertisement, and that's just really wrong, Red Bull. I want you to know that. So, if I don't end up with a Red Bull sponsorship, it's really because Red Bull's unethical. I mean, what else could it be, right? Cheers. Hell yeah! That was awesome. That was great, wasn't it?
That was really good.
Yeah.
Smooth. Smooth.
Yeah.
Like butter.
Okay, guys, I'm out here at the track. As you can see behind me, I have a bunch of cones on the ground. And I have these spaced out at specific distances, mostly 100 feet. And the reason I have that is I bought a drone, which you might be able to tell from some of the shots. I've always wanted a drone, and I needed an excuse to buy one. I think drones are really cool technology. So I bought one. And the reason I bought it is so I can get really high above, and then I'm going to go in and I'm going to figure out my velocities and accelerations based on these cones that I have evenly spaced at certain distances out here. The tanks are leaking somewhere. I think it's at that main ball valve. When I was putting on the one of the nozzles, it twisted slightly, so I think I got a small leak there. That was the one I glued on, and there's that. I almost burned out the pump because when we were putting these cones down, the water drained out of the thing. So I'm feeling like this is probably going to be the last day. This is probably going to be the last day of testing. I want to get at least one more run, which is going to be 1.5 Gs of acceleration, roughly. That's pretty fast. We might get 2. I made enough nozzles to go all the way up to 3, but we're probably, right now anyway, I'm feeling like that's probably not going to happen. I feel like we'll be lucky to get 1 more, maybe 2. I'm excited though. Yeah, let's hope everything doesn't fall apart before we get this next run. All right. The other thing I was going to say is, well, I'm eating a sandwich. That wasn't what I was going to say though. The drone, there's an airport right over there. And the drone, when I turned it on, made me say, "Are you authorized to fly here? Sign here to release all liability and say you have an authorization to fly here." I'm like, yeah, sure, I got that. So I really don't want the, fucking feds to come knocking or, zone in on my, signal and send an assassin drone after me that they're doing to the Russians and Ukrainians. We might be only doing 1 more run. Also, I was thinking, I was talking to Bogdan, the hacksmith guy, and he was saying there is fatigue failure as a problem with aluminum. And generally they say if you have a safety factor of 3, you should be good on fatigue failure. But the more times I pump up and exhaust this system, the more likely the aluminum is to fail. So I don't know, we'll see. We'll see how many runs we do. How'd that look?
Good.
That was pretty fast.
Yeah.
Okay guys, that was pretty cool. I'm definitely done for the day, and the reason for that is this fill hose right here. I forgot it was attached, and when I was pulling it off, it snapped and ruptured. Not dangerous because it's such a small hose, not a lot of energy in there. That was really cool. I'm more calm now after the 1.5 than I was at the 1. Though when I hit the acceleration, when I hit the go button, man, I had a lot of adrenaline. I've been thinking about why there's so much adrenaline, and I think what's going on, all right, I think my lighting is being weird, so I'm trying to adjust it. Okay, so I think it's going on with why I'm getting so much adrenaline from that is because I have like 2.5 hours of anticipation as we're filling this thing up, and there's not a lot of time to practice it. So I don't think the acceleration on this thing is it's not that crazy. In fact, if you brake really hard in a vehicle, you're gonna pull more negative G's than I am pulling positive G's here. But there's something about that buildup, man. It's just and you're strapped to a freaking rocket.
Wait a minute, I just lit a rocket. Rockets explode!
So, yeah, it was fun. We're gonna see if we come back out to do 1 more. I kind of want to do 1 more, but it's also a lot of work to come out here. I don't know if I have another hose. I do need to get this video out. I'm not sure. We might do 1 more. We might call it good. 1 more will be just a little bit faster. I'm gonna review the footage too, but if this is his last time, this has been really fun, guys. So, yeah, we're gonna pack up. I'm gonna head home. Yeah. Bye. What's up, everybody? Just got back from a run, and wanted to finish up this video here. So I took the drone footage and I broke, and using the cones, I broke the distance I was traveling up into 2.5 foot increments, and then I tried to calculate the velocities and accelerations based on those numbers. The problem is that I was not using really a high enough frame rate when I used the drone, and I couldn't get super accurate numbers because of that. But that being said, it looks like I'm only getting max acceleration around 0.5, a little under 0.5 Gs of acceleration, like 0.46, which is really slow because that nozzle was supposed to be 1.5 Gs of acceleration. So I don't know exactly what's going on with that. I don't know if there's problems with the calculations on my nozzle. I don't think that's the case. I'm designing a jet engine right now, and so I've checked those calculations from different directions using different calculations and different methods, and I'm getting the same numbers. So those numbers should be right. I mean, maybe the mass of the bike is too high, me plus the bike, plus all my gear. It's possible, but that doesn't really account for the full thing. It's possible that the way I'm trying to calculate it based on the drone is not correct. I don't really know what the problem is. If you have any ideas, please comment and tell me. I'd love to consider them. Part of me wants to go down to the track and just like put on the big old 3G nozzle and send it. I'm not going to do that. I'm going to finish this video. This video is taking longer than expected. I have other projects I'm working on and stuff too. So, but still, this is, I need to get this video out. I need to move on to other things, and I don't want to die. I think the risk of death is actually pretty low. But I'm trying to do some other very crazy things in my life. I'm trying to break the speed of sound in a suit of powered armor. So I have plenty of risky things I'm trying to do, and this is not the hill I want to die on. All that being said, I think I accomplished something pretty freaking cool. I doubt there's been a bicycle that's ever accelerated this fast. I mean, probably not. If you know of one, let me know. But yeah, overall, I thought it was a pretty cool video, and I had a lot of fun doing it. Part of this video was really just to have fun. That was like one of the goals of this video, and it was fun. It was definitely fun. It was definitely a thrill. Yeah. Thanks for watching. Thanks for getting to this deep into the video. If you liked all this, do me a favor, like the video, subscribe to the video, leave a comment, stuff like that. Thanks, guys. Bye.